Okay, we're about to start. Just please wait a second till everyone gets connected. Hello and welcome back to the Toptal Academy on React.js. I'm Picante Verde and this is lecture 3. I know there has been a couple of complaints about lecture 2 being entirely dedicated to settings and setting up the environment. I know, I understand. Sometimes it's tedious, but it's one of the complications from React that we need to have a complete environment set up before starting to work on our own environment. So lucky for us, now we are going back to React. And as a matter of fact, I just wanted to let you know that it's an issue that they are trying to targeting that React need this much of settings before you can start to write your first line on React. So it won't be strange if in a couple of versions we start to see an IDE or something that help us to get started without that much configuration on your behalf. Okay, so first let's review the assignment for those who are not in this Slack channel. The assignment from lecture 2 was to create table component that will allow you to select an item, and it will change the style or modify the background color or something to identify that one row was selected. So basically, we're going to go through the solution that I made for you. I created a selected component, a selectable component, which is basically rendering a table and rendering the rows that is receiving through the props rows, and just running maps and rendering a table row element with this style. It's going to change the background color to black and the color to white if the state of the component is exactly the same as the index of the row. Also, I'm going to attach an event handler to the onClick on the table row in order to fire the select method with the index of the row, which is going to update the state here using the setState method, which is going to perform, of course, a re-rendering on our component. And then finally, I'm just rendering all the keys from each row, which I think that rows might be an array, and each row would be an object. So I'm going through all the keys and just rendering the content there. So let's see basically how it works. I have a Webpack here running, and I run the HTTP server. on the selectable assignment that I already pushed to GitHub. So if we take a look at this, it looks like this. It renders the table. And whenever I click on one of the elements, it is marking the selection, just changing the style of the row. As you can see, I have the React developer tools here open, so you can actually see that we're rendering a selectable element or component. And we can see the props is the arrays with the elements that we're receiving. And the state is changing whenever we are clicking on one row. As you can see here as well, I have a validating DOM nesting error, which is indicating that I'm not using the table body. So the browser might be generate that for me, but is indicating that React DOM is actually aware of the structure that you are creating, and it will notify you if you are messing around with the DOM and forgetting about the correct structure that you should add. So in order to get rid of that warning, we can just here go ahead and add a T-body element on top of the rows, and finally here as well. Here we are. We have our Webpack notification working as well. And if we reload, there it is. We don't have the warning again, and we have the rendering. So what's going on here? It is I'm rendering the entire component every time I select a row, but we're going to enable this console log rendering line here just to see how many times I'm rendering, actually. So if I'm reload here, every time I select a different row, I'm rendering, but as well, every time that I select the same row, I'm rendering as well. So that's not too efficient. However, remember that we are rendering to the virtual DOM, and then the virtual DOM is comparing the tree of the virtual DOM with the rendered tree of the of the previous virtual DOM tree, and that is going to generate the modifications to the real DOM. So we are not actually performing any real DOM operation here, but we are still rendering to the virtual DOM, and we can optimize that. So we're going to go ahead and we're going to uncomment this line here, which is performing a simple check that every time that I select a table row, I'm checking if the index is the same that is different from the one that I have in this state. So only if it's different, I'm changing the state. If it's not, I don't need to change the state because I don't need a re-rendering. So we save that, and we're going to see that now, whenever we change our selectable index, it is rendering. But if we keep clicking and selecting the same, we are not performing any more renders. So that's it. That's a small performance optimization in order to avoid rendering several times to the same virtual DOM. So how does it work? The selectable in this case is the component that is receiving the rows as a props. We're going to use an arrow to indicate props. It's coming from the outside. I don't think I showed you. Let me show you how this it is instantiated. Here I have in my index.js file, I have my array with all the data, and I'm just rendering the selectable component and sending the rows as the data array just as a property there. So the rows are getting into the component through the properties as an attribute in JSX. And then I'm drawing a table, and I'm performing a check for each table row index. If it's the same as the selected state, then it's going to be rendered with these special styles. And also attaching event handler in the onClick for the table rows in order to modify the selected state. And also, every time I change the state, I'm going to re-render my entire component. So there is a difference between the properties and the state. That's the two places where we have the data for our components. Mainly the difference is that properties are data that is coming from a parent element, or as in this case, from the environment itself. And they are set as attributes in JSX when instantiating our component, and changes not necessarily trigger a re-render. We're going to see examples of this later. And we can send all the data needed. We are going to learn in further lectures how to define optional properties. But it's recommended to accept as many data as possible or as you need for rendering your component. However, the state is a bit different. The state data is data that it's going to change over time in the context of your component, of course. And it's going to re-render every time that we change something on the state. It's going to trigger a re-render of our entire component. And we have to try to minimize the amount of data that we are storing on the state, mainly because we are performing a re-render whenever we are changing the data there. So basically, what is recommended to do on a React application is try to keep your state in the biggest component as you can. For sure, a lot of components will have state, but just keep this in mind. You should try to have an state on your application, and then all your components should receive data through properties. So let's see an example on how we can change our selectable to be working with properties only and not with, to work with properties only and not with the state. So we are going to have a stateless component. So let's see here in the sample 1, I changed the selectable component a bit in order to receive now the rows that we are going to render, an onSelect function, which is going to be an event handler for the onClick for each row, and the selected property. Now, instead of saving the selected property into the state, we are receiving that as a property. So the rendering is almost the same, except that now we are just retrieving the selected index from the properties instead from the state. And the instantiation changed a bit. Now I have an application element that is wrapping our selectable component and is the one that has the state. Now we have the array that we used to have there, and now we're keeping the initial state with get initial state call, and we have a select function that only sets the state of the application, and we are sending these 3 as properties to the selectable. So if we take a look at how it runs right now, it's like this. Server, and let me start the webpack as well. There we have. So now we have our application. We can see here the state of our application has the array and the selected. And our selectable element, it's only receiving props, no longer has any state. And when we click, we can see that it is sending the onSelect property of the selectable element. It's bound to the select method in the application. So that's what it's being executed here. So it's modifying the state of the application, re-rendering the application, which means we rendered the selectable component, and sending the new properties there. So now we have our selectable component implemented in a stateless way. Now, if we are going to check here for the amount of renderings as well, if we just keep seeing the rendering part, every time we select the same row, we're going to see that we keep rendering to the virtual DOM. So how we're going to fix that? Because right now we don't have our own state. The state is managed by the parent component. So for that, we have to review how the React DOM works. And it defined a component lifecycle, which is like the steps that every component goes through. It first gets mounted. It means that it's the moment that when it's going to be inserted into the real DOM, and it goes through three functions. It's get the initial state. If your component is stateful, it's going to call get the initial state before, and then it will call component will mount. And it's important to note the difference that component will mount will be called before you have your DOM elements inserted into the real DOM. And component did mount will be called after you have your component inserted into the real DOM. We're going to see this later when we want to have access to the real DOM and why it's important, the difference. Later for updating, which means every time that it gets re-rendered to the virtual DOM, we're going to have the component will receive props. It means that maybe the parent component is re-rendering and it decided to send new props. So this function will be called. And we can decide, depending on the new props, if we're going to modify our own state or not. Later, we have the should component update function. It's like a hook point that it's going to, it has to return true or false to signalize if the component should be updated, should be re-rendered, depending on the next properties and also on the next state. The same things apply for component will update and for component did update. This is going to happen before the real DOM gets modified, and this is going to happen after the real DOM gets modified. This is going to happen, of course, if should component update return it true. Finally, before removing the real DOM, we're going to call component will unmount. So if you are changing or modifying the real DOM for some reason, you have to keep this component lifecycle functions into your mind and just overwrite the definition, and it will be called by the framework itself. So how do we optimize the rendering in our stateless component? Yes, we can optimize it here and just check if the selected index is the same that we have stored in the selected state in the application. But we are touching like the parent component. And for now, we are working on a small application, it's all right. But when we are developing our own component, we want to provide that functionality as internal to our component. So as we are working with a stateless component, what we're going to do is we're going to override the should component update hook point. And we're going to check if the next props selected, which is the selected property that we're receiving, is the same as the one before on the properties, then we are going to return false. The component shouldn't be updated. So we're going to save this and we're going to give it a try. And now we are rendering whenever we change, but as soon as we keep selecting a row, we are no longer rendering. So we can see that here as well. We are just changing, and you can see that the React developer tools signalize that with a fading color for whatever property is changing at different points in time. Okay, so now, so we talked about stateless component and stateful component. So what's the difference? Stateless are much more simple components. They are only receiving props. And whenever you change the props, it's triggering the re-rendering. On a stateful, on the other hand, they are a bit more complex. They have state. That's why they are stateful. And only the change in the state will trigger a re-render. So key properties and state in sync are not going to be an easy task when you're working with the stateful component. Sometimes you can avoid it, sometimes you don't. So let's going to check example 2. This. Here we are. Let's see. Now I'm going to modify again our selectable component in order to make it stateful. Now it is compatible with what we done before. We still have the rows and the onSelect event handler, but now we're changing the name from the property from selected to initial selected, because it is not recommended to store properties directly into the state. It is always recommended to signalize that that's going to happen with the initial keyword there before the name of your property. This is an anti-pattern. You can check that on the documentation from React. So we're still doing the same thing. We are now controlling again the selected from the state. And if we are going to see this from our application, it looks just like the same. We are just changing the property selected there with initial selected. So let's see how this works. All right, perfect. So if you take a look at this, now it doesn't look that it's working, because now my application, it is changing their state when I select a different row here. If I change there, I have the index 2 selected, the index 1, but the rendering is not being performed. Even so, I'm sending the initial selected property. I'm changing the property of the component. It's not triggering a re-rendering, because selectable, it's now stateful. So when a component is stateful, will only be re-rendered when you call set state. If it's stateless, it will be re-rendered when you change the properties. So how do we make it work? We have these 2 hook points for the component's lifecycle, where we're going to see now whenever the component will receive props, we are just going to store the initial selected, the next initial selected into our own state, which is going to perform the re-rendering. So let's give it a try. And there it is. Now, if you take a look at this here, as we are changing the state in the application, now we are also changing the state in our component. So that's, I hope, good enough representation on how complicated or more complicated it is to work with a stateful component instead of a stateless component. So try to keep that in mind. Try to work with a stateless component, unless, of course, there is no other choice to that, keeping your state on your components. So we can start talking about forms. That is a big subject that we left outside in the first lecture, because on the way that forms elements works in React. Mainly, they have 3 properties that you're going to use to search for the value. Value is the property that is going to work for input of type text and for text areas as well. Remember, this difference is important in text areas, because on simple HTML, you are going to use the children of the text area to modify the content. Here, you are going to use the property value on React. And for input type checkbox and radio, you are going to check the checked property to see the value, if it's checked or not, if it's true or false. And finally, for options, we have the attribute selected, or the property selected, which is the one that is going to give you our value if it's selected or not. Forms element as well provide an onChange event handler, which is going to be called depending on the element. For example, for input text and text area, onChange will be called whenever the value is changed. For checkboxes and radio, onChange will be called when the checked is changed. And for options, it will be called when selected is changed. Also for the select, the onChange will be called when the value of select is changed. So let's give it a try and see. So first, one thing more about form components. We have two way of working with form components, which are called controlled and uncontrolled. You can think about this as the form elements are stateful and they maintain their own state. But you can modify this by just setting the state, the value attribute from the parent element, and you're going to have a controlled component, which is going to behave almost like a stateless element. And if not, you can use an uncontrolled component and just attach an event handler to the onChange event function, so you can see whatever the value it is whenever it changes. So let's see how this works. Let's see the example 3 here. Trying to cover this as fast as I can. There we are. Now, I added a new component, which is called add new form. And the only thing that this component receives is, for now, let's consider the onAdd event handler function there. So let's give it a try to the add new form. It receives this notation is to specify the types of your properties. This will allow the React framework to check if your properties are being sent, and if you forget to connect some property, it's going to trigger an error there in the console, so you can just signalize your component users what is missing. So it is important to use it. In order to use it, there are several types that you can use: func, object, array, and you can even define the content of the array, etc. So keep a read on the prop types in the React documentation. To receive it, it is a named import, so we are using the deconstructing notation from ECMAScript 6 in order to retrieve that. So where were we? Yeah, here. Well, we're going to render the input type text for both for name and for last name. And we are setting the value here. So we are using a controlled version of the input text. And we're listening to the onChange and calling these handler functions. So each handler function, it's going to just receive the event. Remember that this is a synthetic event from React, and it always will have the element in the target. And then we can access the value just through the value property. So we are going to set for name, we're going to set the state name to the target value, and for last name, the same thing. So let's give it a try. Sorry, first, we are going to also have a button to submit our new person there. And we are calling the handle click function here, which is this function that the only thing that it does, it gets the name and the last name from the state, and it just sends it to the event handler. Then the application, it is connected here. It's going to create a new array of the data, and then it's going to push that person into the new array, and it's going to set the state to this new data. So let's give it a try. We are still able to select, and let's say, I don't know, something there, this, and add. Okay, so nothing happened. But if you take a look at the inspector, the new person, it was actually added there, you see? But as we have our component here that is stateful, we are changing the properties. we are not changing, and we are changing the state, it is not triggering a re-rendering. So let's give it this, let's check what's going on there. So what's happening here is that our component, should component update, it's only turning to true if we have a different selected index. So let's give it a try. If we change the selection, it is going to perform a re-rendering, and now we are going to see our new element there. So in order to fix that, we just have to get rid of this code and use a different kind of logic to say, okay, return false unless one of these conditions is true. So if I selected a different index than before, then the component should update. And if the rows are different than before, then the component should update. Okay, so let's give it a try now. Perfect, there we are, right? So that is basically for how forms works. It is a bit tedious to have this add new form stateful component just to work with the controlled elements from the forms. But yes, it's something that you have to do. Remember that the difference for having controller that an uncontrolled element is setting the value property. So if I set here, for example, the value to something like this, then it's not going to receive my client event, and it's not going to allow me to modify the value because the value, it is always being set to that. So that's what it means to be controlled components. So let's see. Perfect. So we can also have references to our DOM element, as I was talking, and also to our, or mainly, to our instances of React elements. And for that, we have the reference attribute in JSX, which is going to receive a callback. Actually, we have two kind of reference attributes, one that receive a callback, another one that receive a string, but it's no longer being used, so avoid it. And the callback will be called with a reference of the instance of the component that you are instantiating there as soon as it gets initialized. So you can store your reference whenever you want to. So let's give it a try and see what we can do. In this case, I'm going to define a clear function. This is going to allow us to call methods on our React component instances. I'm going to define a method clear for add new form, which is only going to set the state to empty strings for both of our keys there. And from the application, what I'm going to do is I'm going to call the ref attribute. Whenever I have the reference for the form, I'm going to store it in this.form. And as I'm adding a new person, I'm just going to attach this callback. This is because set state is not performed immediately. Set state is an asynchronous call. So if you want to do something after your state was set, you have to register that as a callback. If you do it like this here, it's not going to be in the moment when your state was already set. It will be before. So keep that in mind as well. You can just add a callback here and put your code that you want to be executed after your state has been set. So this is going to clear our form when we add our new person. So let's give it a try. And there we have it. You see, now we're clearing our form after we inserted that. Okay, now we have enough elements to start working against our server side. We saw how to use events, we saw how to use the props, the states, but we are still not contacting the server side. So in order to make it work for a server side, well, this is not a course of Node.js, but we're going to see a simple Node implementation. I'm going to show you the code first. Let's give it a try. Close this. And we have here our server code. It's just, I changed the package JSON in order to depend on Express and body parser as well. These are both packages that we're going to need. And I'm just starting an Express and starting an Express application. I'm adding the body parser. This is used to parse JSON content on body of the HTTP request. I'm going to subscribe my API to the /API part of our routes. And then I'm going to serve statically whatever is in the public directory. And then I'm going to start listening on that port. Now the API, it requires Express, it creates a new router, and we have our array of persons here. This should be saved to a database or something. And then we define our routes whenever we have the /API. Remember that we are mounting our router there. /API/person is going to return just the JSON version of the list of persons. For add, it's going to push the whatever is in the body of our request, and it's going to insert that into our array person, and then it's going to respond with the JSON version of the persons. And almost the same thing for del and edit. You can check the code, it's not much complicated. But what is important that I want to talk with you is about tools to work with your API servers. So I'm going to start Webpack here on the server side, and I'm also going to start our server side sample as Node server index. We can also add an ESLint RC there and keep our server. We should keep our server code linted as well. There is this Google application. This is a Chrome application, sorry, which is Postman, which is really interesting to check the functionality of your APIs. So in this case, what we're going to do is we're going to call the localhost 8080. I think that was the port, yes. 8080/API/persons, and it's going to return me the JSON version of the array, which is okay. We can add a new one. To add, we have to set the headers content type to application JSON, because that's the body parser that we have. And we are going to send here as how is it, name and last name. There we are. And we can see that our server is returning correctly. Perfect. Okay, now that's good enough for an introduction to Node.js. And how we're going to connect to the server from our client. Well, we're going to do it through Ajax, right? Well, but what we're going to use the XML HTTP request by hand? No, I don't think so. That's changed a lot across the browser. It's not a stable API for different browsers, so every browser has their own implementation. We're going to use the query Ajax. Yes, we could. Adding jQuery just to use the Ajax, it would be like adding a giant library to just use just a small part. We could have a build version with only the Ajax part of jQuery. Yes, it's a lot of work as well, but well, we can do that. We can use the fetch API, which is the new method to do XML HTTP request. This is going to be across browser someday. But we have the shims if you want to start using today. Or we can use Axios, which is what I'm going to use. which is almost a simple wrap over the fetch API that works the same across server side or client side. So it's pretty much enough for what we're going to do. The thing is that you're going to get used with promises, because Axios is all about promises. So how do Axios work? Well, you have to install it as a dependency, and then you just, whenever you have to do a request, you do the import Axios from Axios, and then you call the post or get, depending the method, and the URL and the data that you want to send. This is going to return a promise, an ECMAScript 6 promise, so you can subscribe callbacks functions with then and catch, etc. You should, of course. In the response, you're going to see the data response in the data property of the response object. The response object is much more complete and have information about the headers and other stuff on the request. So keep that in mind. You always have to access the data property in the response. So when we're going to call the server for our components? Well, for initialization, we're going to call it on the hook point the component did mount. And then whenever we are changing our data, we're going to call as well the server for these results. Remember that our API has this tricky way of working that whenever if I'm listing, it returns the entire list of the persons. If I'm adding a new one, it returns the entire list of the persons. If I'm editing, it returns the entire list of the persons. This is some tricky to make it work in the same way that the state and React works. So keep in mind, how would you implement this with your own API? Actually, that's an interesting thing that you can do as an assignment for the next course. Try to implement a React version of your application with your current project, or with your current project API. So what we're going to have now is on our application, which was the main component in charge of maintaining the state of the entire app, we're going to define a list of URLs. This is just a dictionary that is defining the actions list and the URLs. And we're going to define a fetch function, which is calling Axios and posting to the URL depending on the action and sending the data if I am sending data. And then I'm getting the request, the response from Axios, and setting the state, which whatever the response, the data it is. So in component did mount, I'm calling the fetch method with the list just to retrieve the initial list of persons. And now the rest is the same, but now we have the add method of our application that instead of attaching a new person directly to the array, it is creating a fetch request with the add action and sending the person, right? We are clearing the form before doing the fetch, but we can do it in the then of the promise. So let's give it a try and see if it works. As you can see from the very beginning, we are already receiving the person that we inserted through Postman. So if we add a new one here, it will be added as well. And also I added a button there, which is delete selected. It calls the delete function, and the delete method, it's only calling the delete del action, sending an index. This is because of how the server works. The server API is receiving the index, and then it's using the splice on the array of person and just removing that person from the array. So it is sending the index there from the state.selected. So if we gonna check that, we're gonna get rid of this one. Oh, that's it. And all of this is happening because our fetch function, whenever it receives the result, it is calling set state. So this is because our API, it was designed to work like this. Okay, So good enough for contacting the server. But I would say that that's it with React. We can learn a bit more advanced stuff on React, but they are not as fun or interesting as what is all the tooling or the environments and the other packages that we can add in order to add the functionality to React. As for example, React Router. So our application is getting a bit messy because we have everything here on the application, and we would love to have, for example, editing, and I don't need the entire list for editing. I just want to go to a form, or this form could be on a different page or something. So we can do that using the React Router. And what the React Router is a component that allows us to render a different component depending on the browser route. It will also parse the parameters and inject them through props into our component, and it also provides shim to work against the browser history API. How does it work? Well, first we have to install it as npm install save React Router. And then we have to import these three parts on the main file. And we are going to import another different component from the router in the nav menu, but we're going to see that later. We're going to import the router, the routes, and the hash history. The hash history is the one that it's going to modify the URL in the browser. For now, we're going to use hash history. You can select another kind of history drivers there. And we're going to define a path, and that path it's going to load a component. Like in this case, we're going to render the application. Now we could have several different paths and render different components, but of course we want to have like a container for an application and render components. Different component depending on the URL inside of our application container. So in order to do that, what we're going to do is to add this prop children to the render in the application, and we're going to change these routes in order to look like this. Let me show you. Sorry, this is the router here. There we go. So now, instead of having all the routes at the same level, we are defining like a wrapper component, which in this case is the container. It's going to be our application. And then we are defining routes inside of the main route, which means that all of these routes are going to render this component inside of the application as children. So let's take a look at that. Now, application has this, that props, the children rendered inside the dids, as we saw. Now, I created a nav menu component that it's only rendering the links, which is imported from React Router in order to create this special set of URLs that requires to work against the history that we installed. And it's only receiving an array of options, and those arrays have the URL and a label. So how it's that instantiated from the application is just an array of options with the URLs list and add, as we can see here. So let's give it a try. Now we can see that we are rendering a router context, and a couple of these are a couple of components that the React Router is inserting for us. And we can see our application, and inside of our application, we are rendering the nav menu as we have here, the nav menu, and in the dis.prop children, we are rendering, in this case, the add component there. You see, because I'm in the add URL here. So this is only showing me the, I didn't show you this part. I created, there is a debate on how to organize when you're using like screen or container elements for your components. You can use screens or pages or wherever you want to. You can have that inside of the component folder, but I leave that to you, to your decision. In this case, I'm just creating simple wrappers that are rendering the, remember the new form, the add new form. I just changed that to person form, which in this case, it is receiving the unsubmit, because right now it could be on add or on edit, and a label for the button. And it has the same properties as before. So you're going to see it's almost the same. And now from the add screen, I'm calling the person form and setting the label to add and connecting the unsubmit to add. Now this wrapper, it is going to be in charge of calling the fetch. It's the same function with just the add URL to add a new person. So for listing, you can see here, we're going to list. As you can see, the component changed it automatically. This was done by React Router. So now depending on which page we go, we are loading a different component as the children for our application. So now our selector is allowing us to delete or to edit. We have only 3 because this is a different server. We didn't add a new one yet, so let's add a couple. There we are. So now we can delete this one. Boom. Now the list container, it is performing the same thing. See that I didn't change the selected component at all, but now instead of calling that from the application, I'm just calling that from a container, from a wrapper, from the list wrapper, which is this kind of a string element that it's rendered inside the application container. And I'm performing and sending the same properties there. Now, there is a clever thing that we can do here. For example, to edit a particular option, we can select here and click Edit Selected, which is going to send us to the edit URL. And it's sending a parameter. Let me show you how that behaves in the router here. I'm defining the edit path with an argument here. This is a parameter. So whatever comes here, it's going to be automatically set inside of the params properties in the, oh my, this is still called add. Wow, that's, I will fix that before pushing. So it is sent as a parameter here. So we can retrieve this IDX from the parameters of the URL. This is a bit tricky, but when you are settled down and review the code by yourself, you're going to be able to realize how it works. But the important part here is that in order to be able to do that, I have to use something that it's called the context. So far, we saw that we have only 2 ways of send data to our component, which were the properties and the state. There is a 3rd way, but this is left more for libraries and stuff because it's an API that is subject to change. And believe me, they are going to change that a lot because React itself, it's a library subject to change. So keep in mind, try to avoid the use of context. So I'm going to show you just how to retrieve something from the content. The router itself, it's being published through the content. So all the components in the tree will have access to the router. So in this case, what I'm doing is just defining my context types. Then I'm going to receive a router, which is going to be an object with the same prop types notation. And then I can call this .context.router, And the router itself has a method push to send a new route. This is like to perform the URL change for you instead of using the links elements that we saw in the nav menu. So here the list is doing that here in the context type and receiving. And whenever you click on the edit button to edit the selected one, it's going to retrieve the selected index from the state. It's going to create the route, and then it's going to push that route to the router. So we are now able to modify the selected one. There it is. If we change something here and we say edit, it's not automatically being sent the response, but there it was. So if we go to the list, we have the changes there. That's it. I think I covered the entire hour. I hope that you really enjoyed this lecture. I apologize again for the settings part, but it is one of the difficult parts of React, so I wanted to dedicate enough time to have a common understanding on how things work under the hood for converting this ECMAScript 6 into something that the browser can understand. For the next lecture, it's going to be important that you have some practice on this because I want you to realize that this is just too messy to create a big application. We have the fetch function on every screen. We are retrieving data a lot of time. This is completely inefficient, so we need to solve this problem. And we are going to solve that through the Flux architecture and the Redux implementation on the next lecture. So see you then, guys.